There are certain moments in life that don't arrive with explosions or panic. They arrive quietly, almost gently. A moment where something you believed you understood suddenly stops making sense. You're standing there with your carefully built understanding of reality, and reality calmly answers back with something that doesn't fit. Not close, not even slightly. And in that instant, the only honest response is to admit something most people hate admitting. I don't know. That is exactly where modern cosmology finds itself right now. Because somewhere deep in the darkness of the early universe, the James Webb Space Telescope has found something that should not exist. And I want to be careful with those words because science deserves precision, especially when the temptation is to become dramatic. Every time astronomy discovers an anomaly, people rush toward sensational explanations. Suddenly it's aliens, simulation theory, the collapse of physics, the end of everything we thought we knew. But real science doesn't work that way. Real science moves slowly, carefully. It resists the urge to turn confusion into certainty too quickly. Still, there are moments when the universe sends back data so strange that even cautious scientists pause and say, something is wrong with our picture. This is one of those moments. The James Webb Space Telescope was designed to look farther into the past than any instrument ever built. Because light takes time to travel, looking deep into space also means looking deep into time. Webb can observe galaxies whose light began traveling toward us more than 13 billion years ago, meaning we see them as they existed shortly after the Big Bang itself. And according to our best cosmological models, the early universe should have looked young, chaotic, and unfinished. The first galaxies should have been small, messy, irregular collections of early stars still struggling to organize themselves. That's what decades of calculations predicted. That's what our simulations said should exist. But Webb found something completely different. It found galaxies that appear far too massive, far too bright, and far too evolved for their age. Not one or two isolated examples. A growing pattern across multiple observations and independent research teams. Entire galaxies that look mature at a stage in cosmic history where maturity should have been impossible. Imagine expecting to find small villages at the beginning of civilization, and instead discovering fully built modern cities already standing there. That's the scale of the problem. Now, it's important to understand this carefully. The data itself is not being dismissed. These observations are real. The question is not whether something strange is being measured. The question is what it means. The most conservative explanation is that our understanding of early star formation is incomplete. Maybe stars formed much faster in the early universe than we expected. Maybe matter clumped together more efficiently under those ancient conditions. If that's true, then the larger framework of cosmology survives. We simply revise some details inside it. But there are other possibilities, more unsettling ones. Some physicists now wonder whether the expansion history of the universe itself may be different than our current models suggest. Perhaps dark energy behaved differently in the beginning. Perhaps the early universe evolved under conditions we do not yet understand. And then there's the possibility sitting quietly at the edge of the conversation. The one serious scientists rarely say loudly but increasingly cannot ignore. What if something about our entire picture of cosmic history is fundamentally incomplete? That possibility matters because physics has seen this pattern before. Tiny anomalies have changed everything in the past. The strange behavior of blackbody radiation eventually led to quantum mechanics. Small irregularities in Mercury's orbit helped reveal general relativity. Unexpected results surrounding the speed of light transformed our understanding of space and time themselves. Most anomalies disappear once we gather more data. That's true. Many apparent revolutions end up being measurement errors or misunderstood assumptions. Science demands humility because nature has embarrassed human certainty many times before. But sometimes the anomaly survives. And when it survives, it changes the world. That is why scientists are paying attention to Webb's discoveries with such seriousness. Not because they already know the answer, but because they don't. Because the universe may be revealing a gap in our understanding large enough to reshape modern cosmology. And honestly, I think there's something deeply meaningful about that. We live in a strange moment in human history. We often talk as though science has already explained almost everything important, as though the universe has become predictable, mapped, categorized, understood. But then something like this appears. Ancient galaxies from the edge of time itself, sitting in the data like impossible messages from a reality older and stranger than expected. And suddenly we remember something important. The universe is still ahead of us. After centuries of equations, telescopes, theories, and discoveries, reality still has the power to surprise us completely. That matters more than people realize. Because a universe that could no longer surprise us would be a smaller universe. Not physically smaller, but smaller in mystery, smaller in depth, smaller in possibility. But this universe is not exhausted yet, not even close. And what Webb may be showing us is not just a scientific puzzle, but evidence that the deepest layers of reality are still waiting to be uncovered. Because the farther scientists look into the beginning of time, the more they are starting to suspect that something about the early universe itself may not match the story we've been telling ourselves for decades. And if that's true, then what comes next could become one of the biggest scientific revolutions of our lifetime. If you're still watching, subscribe now, because this is where the story begins to move beyond galaxies and into something even stranger. The possibility that the universe itself may have started in a way we still don't understand at all. The deeper scientists look into these impossible early galaxies, the harder it becomes to ignore a disturbing possibility. Maybe this is not just a small error in calculation. Maybe the universe is pointing towards something much larger, something hidden beneath the surface of modern cosmology itself. Because when a theory works beautifully for decades and then suddenly fails in a place where it should have succeeded, scientists pay attention. Not because they want the theory to collapse, but because reality always matters more than comfort. The universe does not care how elegant our equations are. If the observations disagree with the model, then eventually the model must change. And that brings us to one of the strangest ideas in all of physics: dark matter. Right now, according to everything we observe, most of the matter in the universe is invisible. Galaxies rotate too quickly to hold themselves together using visible matter alone. Massive clusters bend light through gravity far more strongly than ordinary matter can explain. The structure of the cosmic web itself only makes sense if enormous amounts of unseen mass exist throughout the universe. We call that invisible mass dark matter. But here's the uncomfortable truth. We still do not know what dark matter actually is. We know something is there because gravity keeps revealing its presence, but every attempt to directly detect the particles responsible has failed so far. Scientists have built underground detectors, space experiments, and enormous collider systems searching for it. Yet the true nature of dark matter remains one of the greatest unsolved mysteries in science. And that matters here because dark matter plays a major role in galaxy formation. According to current models, dark matter acted like a kind of gravitational scaffolding in the early universe. Ordinary matter collected around it, eventually forming stars and galaxies. But if dark matter behaved differently in the beginning than we currently assume, then everything changes. Maybe it clumped together faster. Maybe it interacted more strongly. Maybe it possessed properties we haven't even imagined yet. If any of those possibilities are true, then the first galaxies could have formed far earlier and far more rapidly than expected. The impossible galaxies Webb is observing might not violate physics after all. Instead, they may reveal that we misunderstood one of the universe's most fundamental ingredients. But there's another problem sitting quietly beneath all of this. And unlike Webb's galaxy observations, this issue has been haunting cosmology for years. It's called the Hubble tension. At first glance, the problem sounds technical, but the implications are enormous. Scientists use something called the Hubble constant to measure how quickly the universe is expanding right now. The strange part is that when astronomers calculate this expansion using nearby galaxies and supernova observations, they get one answer. But when they calculate it using the cosmic microwave background, essentially the ancient light left over from the Big Bang, they get a different answer. And the difference refuses to disappear. As the measurements become more precise, the disagreement becomes stronger. That is deeply unsettling because modern cosmology depends heavily on the expansion history of the universe. If our measurements of expansion are wrong, then our estimates for the age and timing of cosmic structures may also be wrong. Galaxies that currently appear too old for their age might actually fit a revised timeline, or the opposite could happen. The inconsistency could reveal that something important is missing from our entire model of cosmic evolution. That possibility is what keeps many cosmologists awake at night. Because once you start questioning the expansion history of the universe, you inevitably move toward even deeper questions. Questions about the earliest moments of existence itself. And this is where physics begins approaching a wall. There is a point in cosmic history where our best theories stop working together. On one side stands general relativity, Einstein's theory explaining gravity, space-time, black holes, and the large-scale structure of the cosmos. On the other side stands quantum mechanics, the framework governing particles, atoms, and the microscopic world. Both theories work extraordinarily well, but under the extreme conditions of the early universe, they break apart. At the first tiny fraction of a second after the Big Bang, the universe was unimaginably dense, unimaginably hot, and unimaginably small. In that environment, gravity and quantum mechanics should operate simultaneously. But we still do not possess a confirmed theory capable of fully uniting them. This missing theory is known as quantum gravity, and it may hold the key to everything. Scientists have proposed possibilities. String theory suggests that the fundamental building blocks of reality are not particles at all, but tiny vibrating strings existing across hidden dimensions. Loop quantum gravity imagines spacetime itself as quantized into microscopic units. Other models propose entirely different structures beneath reality, but none have been experimentally confirmed. That is why Webb's observations matter so much. Because these ancient galaxies may contain fossil evidence from a regime of physics we have never directly observed before. Not just new astrophysics, not just revised galaxy formation models. Potential clues about the deepest structure of spacetime itself. Think about how extraordinary that possibility is. Light that began traveling over 13 billion years ago may now be carrying information from a period of cosmic history where our current understanding of reality completely breaks down. That is not a small scientific adjustment. That is the edge of human knowledge. And honestly, there's something profoundly beautiful about reaching that edge. There's a certain kind of feeling that appears when reality contradicts your expectations. Not excitement exactly, something deeper than that. A mixture of discomfort, curiosity, and awe. Because moments like this remind us that science is not the process of defending certainty. It is the process of surrendering certainty when the evidence demands it. The universe is not obligated to match our assumptions. It does not rearrange itself to preserve our comfort. It simply exists as it is. And every once in a while, it sends back information so strange that humanity is forced to stop and reconsider the map we've been using to navigate reality. That willingness to reconsider, to genuinely let the evidence reshape the picture, is one of the most important qualities science has ever developed. But I think it also applies to life itself. Because most people move through life believing they already understand the world around them. They build stable mental models about who they are, what matters, and how reality works. Then something unexpected arrives, a discovery, a loss, a conversation, a realization. Suddenly the map no longer matches the territory. And in those moments we face the same choice science faces. Defend the old picture. Or let the new information change us. The James Webb Telescope is forcing cosmology into that exact moment right now. And the deeper scientists investigate these impossible galaxies, the more they are beginning to realize something unsettling. The problem may not be the galaxies themselves. The problem may be the story we've been telling about the beginning of the universe all along. And what that could mean becomes even stranger once we begin talking about time itself. Because the next layer of this mystery leads directly into one of the most unsettling questions in physics, whether spacetime itself emerged from something deeper that we still cannot see. The strangest part of this entire mystery is not the galaxies themselves. It's what they may be telling us about time, space, and the structure of reality underneath everything we think we know. Because when scientists look far enough into the universe, they eventually run into a terrifying limitation. Our equations stop making sense. There is a moment near the beginning of cosmic history where modern physics breaks apart completely. Einstein's relativity, which explains gravity and the large-scale structure of space-time, collides with quantum mechanics, which governs the microscopic world of particles and probabilities. Both theories are incredibly successful on their own, but under the extreme conditions of the early universe, they cannot fully coexist. And that failure matters more than most people realize. It means that at the deepest level, humanity still does not know what space-time actually is. We treat space and time as the background stage where reality unfolds, but many physicists now suspect space-time may not be fundamental at all. It may emerge from something deeper, something more basic than geometry itself. That possibility sounds abstract at first, but the implications are enormous. Imagine discovering that space is not truly space, that time is not truly time, that what we experience as reality is a kind of surface effect generated by hidden structures operating beneath perception. This is no longer philosophy. Serious theoretical physics has been moving in this direction for years. Some versions of quantum gravity suggest space-time is woven from microscopic informational units. Others propose that the universe behaves more like a hologram, where the three-dimensional world we experience emerges from encoded information on a lower dimensional boundary. In certain interpretations of string theory, reality itself may consist of vibrating structures existing across dimensions far beyond the three spatial dimensions humans normally perceive. And if any of those ideas contain truth, then Webb's ancient galaxies may be revealing traces of physics from before ordinary spacetime fully stabilized. That is the part that becomes difficult to emotionally process. Because we are used to imagining the Big Bang as a beginning, a single explosive event from which everything emerged. But technically, the Big Bang theory does not fully explain the actual beginning itself. It describes the expansion of the universe from an extremely hot, dense state. But the deeper question, why that state existed at all, remains unanswered. And maybe the early galaxies are hinting that the answer is stranger than we expected. Some physicists now wonder whether the earliest moments of the universe contain structures, fluctuations, or forms of organization carried forward from a deeper quantum reality. Tiny irregularities amplified over billions of years until they eventually shape the galaxies Webb now observes. If that's true, then those impossible galaxies are not merely cosmic objects. They are fossils from a regime of reality we have never directly understood before. And what I find remarkable is how deeply human this process actually is. People often imagine science as cold certainty, equations, data, precision, but real discovery rarely feels stable. It feels disorienting. It forces you into direct contact with uncertainty. There is a very specific emotional texture that comes when reality contradicts your assumptions. Anyone who has worked deeply in science eventually encounters it. That moment where you realize the universe is not obligated to fit your expectations. And strangely enough, those moments are often the most alive moments of all, because certainty has limits. Once you believe you fully understand something, curiosity begins to shrink. Mystery disappears. Wonder fades into routine. But when the universe surprises you, genuinely surprises you, something opens again. You remember that reality is still larger than your picture of it. I think that matters far beyond physics. Most people live with internal models about how life works. We build assumptions about relationships, identity, success, meaning, even ourselves. Those models help us navigate the world efficiently. But eventually life sends back information that doesn't fit. A moment arrives that forces revision. And revision is uncomfortable. Human beings naturally resist it. We defend our prior assumptions because they make reality feel stable. But growth, whether scientific or personal, only happens when we allow new information to genuinely change the picture. Physics survives because it accepts this principle completely. A theory is never sacred. No matter how elegant, successful, or beloved it becomes, the evidence always comes first. If reality disagrees with the theory must eventually bend. That intellectual humility is one of the greatest achievements of science. And honestly, I think it's also one of the hardest things to practice in ordinary life. Because most people do not struggle with lack of information. They struggle with attention. The universe is constantly sending signals. Other people are constantly sending signals. But receiving a signal requires presence. Real presence. Not proximity, not partial attention. Actual openness to what is being communicated. And that is far more difficult than it sounds. You can stand beside someone physically while mentally existing somewhere else entirely. You can hear words without receiving meaning. You can move through life half absorbed in your own internal noise while the important signals pass quietly by unnoticed. I think about that often when I think about cosmology. For over 13 billion years, ancient light traveled across expanding space-time carrying information about the early universe. That information existed long before humanity appeared, long before Earth formed, long before there were telescopes, physicists, or conscious observers capable of interpreting it. The universe was speaking long before anyone could listen. And then eventually, through chemistry, evolution, biology, and consciousness, matter organized itself into creatures capable of catching the signal and asking what it means. That's us. When you really stop and think about it, that is extraordinary. Humanity is a temporary arrangement of matter that became capable of understanding the history of the cosmos itself. Not perfectly, not completely, but enough to build instruments that can detect ancient photons arriving from near the beginning of time. We've become the universe, examining its own history. And yet even now, after all our discoveries, reality still exceeds our understanding. The deeper we look, the stranger things become. The early galaxies Webb observes are reminders that mystery is not disappearing, it is evolving. And maybe that's exactly what keeps science alive. Not certainty, not closure, but the persistent realization that there is still more beyond the edge of the current map. The galaxies shouldn't exist according to our best models. Yet there they are, sitting patiently in the data, waiting for humanity to decide whether we are willing to let reality revise the picture once again. There's something deeply uncomfortable about realizing your picture of reality is incomplete, not because human beings dislike learning, but because we depend on stability more than we usually admit. We build mental structures to make the world manageable. We create routines, identities, explanations, and expectations because uncertainty is exhausting. It drains us. And over time, we begin mistaking our models of reality for reality itself. Then something unexpected arrives. A signal from deep space, a scientific anomaly, a personal loss, a conversation that changes everything. Suddenly, the structure we trusted develops cracks, and we are forced into one of the most difficult experiences a human being can have. We are forced to genuinely look again. That is what makes these discoveries from the James Webb Space Telescope feel larger than ordinary scientific news. They are reminders that reality is still alive beneath our assumptions. The universe is not finished revealing itself. And honestly, I think the same is true about people. One of the strangest things about getting older is realizing how much of life happens while your attention is somewhere else. Most people assume major moments announce themselves dramatically, but they usually don't. The moments that shape a life often arrive quietly, buried inside ordinary time. A conversation at dinner, a moment of silence, a small request for attention, a look on someone's face that you noticed but didn't fully receive. Then years pass, and suddenly you understand that those moments were not small at all. They were the texture of your actual existence. The real structure of your life was hidden inside details you treated as background noise. I think science and life share this same problem.